Yes, I'm trying to cover 13 different subtasks in 15 minutes, so it will be very brief. But task 13 is about performance, operation, and reliability, and it has these 13 different subtasks. The Danish, there's no Danish, not Danish representation in all of the tasks, but at least we will. I will bring you through all this. The first subtask is about degradation modes in new PV cells and module. And there we have a strong Danish participation by Sergio, and he will bring you through the details of this subtask a little later. So I will skip this slide. The second subtask is about second life PV. So how to repair modules or how to classify modules that might have a second life. There's no Danish participation in this subtask. You can see that it's something about repair strategies and also trying to identify new markets for modules that are taken down. As an example, you have these two examples that the pictures to the right illustrates how it may be useful to use drone systems or other classification methods to figure out which of the modules are actually operative or defect before they are demounted. And the other illustration to the left is showing how some kind of repair could take place in a factory, most likely before a final module is shipped to the customer, but nevertheless a module that might have been classified as a defect and not a sellable product might be repaired in the shop before it's finished. So it's not a topic that I think we need to consider in depth, but at least it's a part of this task 13 program to address such topics. And like with all these 13 subtasks, this will just be an appetizer. Yeah, I will not be able to go into details with any of the subtasks really. This subtask 1.3 is about load factors and accelerated testing. So today, when you buy a module, it's certified according to the IEC standard. But what was actually the objective of having this certification in the first place, and what are the character of the loads that you are supposed to meet to get this certification? This is something that should be revisited, since today you have much more diverse applications of solar modules. So maybe you should consider if you need the same kind of stress test of a module to be deployed in the desert as to the rainforest or in an Arctic environment. And if you have ambition to install it in the Arctic, what kind of stress tests should you apply on the module to make sure it's actually suited for that application? So that's the topic of this subtask 1.3, and it's also about how to combine different stress tests in sequence or in combinations to make sure you get around the most likely problems that might occur with a module under the given installation conditions. Subtask 1.4 is about the reliability of PV and storage. So in this subtask, the discussions point, as you see up to the right, are about metrics, performance metrics. It's about degradation, and it's about reliability and operation and maintenance. But to have a discussion on metrics and O&M and so on a battery system cannot be decoupled from the type of installation or type of use of the battery. So you have to consider the specific use case and which in this case is divided into these time shift. I'm looking at the black text to the left, time shift of the production, some market operational things, or resilience objectives, or the last thing to deliver ancillary services and so on. So depending on the type of application, you will have different metrics of being relevant, and this is all addressed in this subtask. I believe they will make a very interesting and strong report eventually. There's something about floating PV, both inland floating and offshore floating. The ambitions here are both to do some modeling, but also to address O&M topics and degradation modes and so on. But I wrote here that Adam would say something about this. Probably he will not, because he has chosen to focus on his contributions to task 16 instead. But then the very short overview here is that floating PV is also addressed in the task 13, and eventually there will be a report on this. Adam is still contributing to this, actually, even though he will not disclose the details today. Photovoltaics is another topic within task 13. I'm trying to contribute and have just delivered a chapter on financial modeling on agro PV systems. That's the last chapter 7, you can see down there. But the illustrations are covering some of the topics in this subtask. The picture up to the right reminds us that a lot of the discussion today is actually about classification and what is considered actually agro PV. This is a high over type of structure, it's called, when you have trackers that are above the field. Then you have the interspaced system below there. Both are actually European energy activities. The trackers to the left are harvesting grass, and the picture to the right is from the test site out here at Risø we just visited. It's actual potatoes that are being grown underneath and between the trackers here at Risø. So those are our topics for agro PV. Then subtask 2.3, bifacial tracking systems and modeling. Here you have to wait for Nicholas's presentation. I introduced a little bit out in the field why we had the test field and what the important is to have good PV models. And this is what Nicholas will elaborate on. He is contributing to this subtask. Subtask 2.4, digital integration and digital twinning. There's no Danish participation in this subtask. The topics might be not so familiar for most of us, but basically it's about all the data that are available to ensure that they are made use of. Take some tools to collect the data, some analysis to figure out what kind of actions should be made out of these data. But in general, there's a lot of activity and potential in having these digital twins of PV parks and PV systems. Again, it takes also some effort to make sure you classify things correctly or in a systematic way, and you have access to the data. But it's a subtask where there also will be I'm pretty sure a quite interesting report within a year or so. Subtask 2.5 about module level power electronics. There's participation from Denmark by Toge Franke, who is from SDU, and he's supporting Franz Baumgart on such analysis of the capabilities and performance of module level electronics these illustrations or pictures is just a mess of pictures I've taken from other presentations that demonstrates that something about shading and how to figure out what is the real efficiency of an inverter or the module electronics under various load conditions, because it's seldom that the electronics will operate at the rated or appraised conditions. So that's a lot of studies that are being done in this field in this subtask 2.5. Subtask 3.1 is the big topic of catastrophic failures. So extreme weather events and the impacts. It's maybe not super interesting in a Danish context, but when you follow the work they are doing, you can see that there are a lot of possibilities for catastrophic failures. So just listed below there: hurricanes or typhoons, high wind speeds, hailstorms, snowstorms, dust storms, heat waves, floods, wildfires. So eventually there are actually a lot of things to look out for, and the topic, and then it's not enough just to observe these things, but also to try to figure out what are the impacts by these different KPIs. In this example, it's the economic impacts of hurricanes and typhoons, where they illustrate how they could address this by looking into insurance claims, and also technically on hailstorms, where there are a lot of discussion on exactly how to mitigate it by maybe using stronger glass or thicker glass and so on. So next subtask 3.2, it's a more generic type of subtasks. So it's all about how you could consider to optimize this system design specifically for a specific climate, whether like it's hot and arid, it's hot and humid, or cold and snowy climates, and what are the type of considerations and opportunities to select material and components dedicated such specific climate conditions. So again, a subtask where a lot of reports will be made. I think this is actually the last subtask of all these. Impact of decisions in PV projects, economic and KPIs. So it's an activity where the workflow in a PV project development is being mapped and analyzed. So what are actually the different steps in a PV project development phase? What are the concerns and analysis and activities that are included in each step of the work? And here you see that the phases is like from development, engineering, procurement until operation and decommissioning. But the stakeholders might be quite different, whether it's a bank or neighbor and so on. So map all the activities and interactions between stakeholders in these different phases, and try to provide a KPI or some concepts about this. I think it might be, there was one more, mapping of economic and reliability KPIs, So also something about mapping of KPIs from various project phases. So that was a quick tour of all those subtasks in task 13, and some of them with Danish participations, some where you will get some extra information later, and some where you might have heard of something interesting that you can ask me about later on. Then I will try to provide more information or share what I do have.